The overall goal of the aortic ring assay is to provide a flexible experimental system in which blood vessels are sprouted from whole pieces of mouse aorta inside a 3D matrix. This is achieved by first dissecting the thoracic aorta out of a mouse, and then carefully cleaning it of any leftover surrounding tissue. Slices of the cleaned aorta, or aortic rings, are placed into individual wells of a 48-well plate, each holding basal matrix extract, or BME, molded into domes. An extra drop of BME encloses the ring in a 3D structure. The matrix can contain any experimental reagent of choice. After incubation for several days, vessels can be observed to sprout from aortic rings, and the angiogenic potential of test compounds can be assessed.
Hi, I'm Karen Belassen from the laboratory of Dr. Eli Lewis in the Department of Clinical Biochemistry at the Ben-Gurion University of the Negev in Beersheba, Israel. Today we will show you a procedure for mouse aortic ring assay. We use this procedure in our laboratory to study the effects of various materials on blood vessel formation. So let's get started.
To begin this procedure, allow the basement matrix extract, or BME, to thaw on ice or at 4 degrees Celsius. Once thawed, continue to keep the BME cold to prevent it from solidifying again. On the day of the experiment, euthanize a 6 to 7 week-old mouse by a standard ketamine and xylazine injection. Bleed rapidly through the neck arteries, followed by cervical dislocation. Begin the procedure by wiping the animal with 70% ethanol in a sterile laminar flow hood. Next, while working under a dissecting scope, use sterile forceps and dissection scissors to perform a vertical incision of the skin and open the peritoneal wall. The incision should be made to expose the upper sternum, where the rib cage is also cut and the diaphragm removed. Proceed to carefully push all the organs aside, completely exposing the thoracic aorta, located alongside the spine. With the aorta exposed, insert thin, sterile tweezers between the aorta and the spine, spread the tweezers open, and gradually lift the aorta from its bed, separating the thoracic segment from the rest of the aorta. Now that the aorta is separated, use sharp scissors to cut it away from the mouse, starting on the end, which is in close proximity to the renal vessels, and ending near the heart. Place the excised thoracic aorta in a petri dish filled with cold, sterile PBS. Now that the aorta is removed, the aortic rings can be prepared. Using 2 sterile tweezers and working under a binocular, clean the thoracic aorta from surrounding fat tissue. Make sure not to damage the aorta and hold it only at the edges. The aorta should be repeatedly immersed in the PBS-containing petri dish to prevent dehydration until it is finally cleaned. Now that the thoracic aorta is clean, use a surgical blade and work under the binocular to slice the aorta evenly into 1 mm rings, using a ruler placed below the cutting surface as a guide. Make sure to use a new blade and replace it from time to time to maintain sharpness. The ends of the aorta are not used. After cutting each ring, use tweezers to transfer it very gently into a new dish containing cold PBS. Place all the rings in the same PBS-containing plate to ensure that the assay is randomized, since each segment of the aorta has a somewhat different angiogenic potential. Keep the rings on ice. Next, prepare the assay plate. Using pre-cooled pipette tips, Add to each well in a 48-well plate a rounded drop of 150 microliters cold BME. The drop solidifies to a dome mid-motion. The BME allows transport of substances, chemotaxis of cells, and most importantly, cell differentiation and migration that leads to neovessel formation. Perimeter wells are filled with PBS to avoid BME dehydration. Allow the BME drop to solidify at 37 degrees Celsius for 20 to 30 minutes. Once the BME has solidified, carefully lift out an aortic ring from the petri dish using tweezers. In order to prevent damage, the ring should be transferred inside the drop of lipid that forms between the tweezer tips as a result of liquid surface tension. Place a single aortic ring in the top center of each dome and incubate for 10 minutes at 37 degrees Celsius. On top of each ring, add an additional 150 microliters of BME and incubate for 20 to 30 minutes at 37 degrees Celsius. The ring is now encased in BME and assay materials can be added to the plate. To initiate the assay, pre-supplement previously prepared human endothelial serum-free medium with either the experimental material or endothelial cell growth supplement as a positive control. For a negative control, use medium alone. Add 500 microliters of the pre-supplemented medium to each well and incubate at 37 degrees Celsius for 6 to 12 days. During this incubation period, examine the plate under the microscope and look for vessels sprouting from the aorta, and for advanced mature vessels identified by further branching. Vessels should extend in from the ring tissue three-dimensionally. Photograph the rings between day 6 and 12 under standard phase contrast stereoscope. In addition, collect supernatants on various days between day 6 and 12 and store at 4 degrees for use within a day, or aliquot and store at -20 or -80 for future use. The supernatants can be analyzed by various techniques, such as ELISA for VEGF or grease assay for nitric oxide levels. These images were collected 12 days after placement of rings in the wells and incubation with either culture medium, seen in the top row of images, or ECGS used as a positive control for vessel sprouting, seen in the bottom panel. Each image is a representative snapshot of 4 out of the 12 rings, which is typically used in the assay per condition. The corner of each aortic ring in each separate well is black when photographed this way. Aortic rings that were exposed to ECGS exhibit vessel growth, and the arrows point to several of the many vessels that have formed. Each vessel is characterized as chains of endothelial cells with occasional branching, indicating that they are mature. No sprouting vessels can be observed in the culture medium wells in the top panel.
We've just shown you how to perform the aortic ring assay. When doing this procedure, it's important to remember to work accurately and under sterile conditions. So that's it. Thanks for watching and good luck with your experiments.